Good afternoon.
Good afternoon, sir.
Yes. So to continue from the previous class, no, I don't know. Today we had a alumni talk. I could not see many of you. A couple of you were there. What happened to others? Why you are not part of it? Fine. May I have the solution for the problem where we stopped yesterday? That is object program. If anybody has done, can project.
Sir, I'll share.
Okay. What is the 300 equivalent hexadecimal?
Sir, 012C.
You want to see. Okay, perfect. Okay, done. So we kept on adding 3 times.
Yes, sir.
Okay, fine. So can you show one object code generation for any instruction?
Yes, sir.
Just maximize any one.
So this is first one.
Okay. LDS 3. What LDS 6C?
It's for app code is 60.
C means how much?
C is 12.
Okay, fine. Next. Okay, done. Okay. Show me any other instruction other than immediate.
Sir, here LDA alpha, comma X.
Okay.
Fourth instruction.
0, 0, n and I 1, x also 1, PC is equal to 0. Right. Okay, done. 1019 C 00D. Right. Good. So you should write now in the format H comma T comma. Have you written that?
Yes, sir. This is.
Okay. Very good. Good. So when you write the object code, you should make sure that you have 3 bytes or 4 bytes. 9041 is not right, no? You should write 009041.
Where, sir?
T record, second T record.
19.
So 9041 is only 2 bytes. Okay, your instruction is 2 bytes.
Sir, we have to write 6 bytes, sir.
No. Sorry. No. You have a 2 byte instruction, no?
Yes, sir.
For that purpose. Perfect. No issue. Correct. Okay. Done. Correct ಇದೆ. Good. Okay, let us continue now. So we'll go with the next question. So hope the screen.
Sir, in that I have one doubt, sir.
Tell.
Like in the text record, for how many instructions we have to write in one, like for one text?
No, that's why the length is fixed. No, 10 to 69.
10 to 60.
Once
So
it reaches
based on
69,
calculating the address size, we have to
that's
write.
why 1 to 69, 10 to 69 means 69 minus 10.
59.
Each instruction takes either 2 characters, 4 characters, 6 characters, 8 characters. If it is a 3-byte instruction, 6 characters. If it is a 2-byte instruction, 4 characters. So like that, you can count and fix it. In the exam, don't worry too much. Nobody is going to penalize you if you don't calculate.
Okay,
whatever
sir.
you have written now is enough for the exam. You have to show in the format. That's important.
Okay, sir. Thank you.
So from exam point of view, not a problem. But learning point of view, where to stop is until you go to that 69. But what you have to keep in mind is that suppose there is an instruction which starts at 68. You can't write 2 bytes in first text record, another 2 bytes in the next text record. No. One complete object code should be in the one text record. If that is the case, we end at 67 itself. Now we'll not go to 68, 69. So like that. So one complete instruction should be in one text record. There is no 50% or 60% splitting. That should not happen. Fine. So hope the screen is visible now. So let us look at the next question. The relocatable program, the concept of program relocation, which is important. We have been talking about this for a long time. Our internals, we had this relocation, why it is required, how we can mitigate this using modification records, and how these diagrams, what you have taken 5,000, 7,000, 10,000 like that, they are going to help us to understand, and all those stuff with some example. That's what the concept of a relocatable program. Okay. So next is, that is second module done with the assemblers. So second module, we have one more choice for you. Write an algorithm for one pass assembler. So we have not discussed assembler algorithm. We know only one pass assembler design. But look at the question today. The question is, write an algorithm for one pass assembler. So what we have to do here is now, 2 things we have to touch, because it is asked for 12 marks. You should discuss about the design of one pass assembler, where forward references will be handled using linked list. And second, whatever the algorithm we have for normal 2-pass assembler, that we have to tweak to contain the linked list concept. So since there is no one-pass assembler algorithm which we have discussed, but whatever the algorithm we have for pass 1 and pass 2, you can club together and make one simple assembler, wherein the forward references, instead of going to the symbol table directly, they will have some references. That part we have to add. Otherwise, you need not generate a separate algorithm here. You have to wisely combine pass 1, pass 2 together and make sure that both represent a single algorithm. That part you have to cleverly do that. Otherwise, there is no much thing to be done under this. So that's how we have to think. Because in syllabus, we never discuss one pass assembly algorithm. It's only design. When the question is asked like this, you need not be surprised or panic. So write the design of one pass assembler, which talks about forward references handling using linked list. And accordingly, whatever the algorithms you have for pass 1, pass 2, club them together, make them one single pass and write continuously. That's all we have to do here. And of course, MASM assembler is one of the implementable or practical example, which you have written assignment as well. So that's what we said. Assignments are not for the sake of assignment. They will also be very important from exam perspective. So hope you have written assignments with that perception. So this concludes your second module. So let us get any doubts till this? What type of questions being asked or how to answer till module 2? So let us get into the module 3 now, which talks about loaders. So what are the functions of a loader? So here if you simply write 4 functions, that is not going to be sufficient. We have to write how program memory allocation is done, how linking is done, how relocation is done, how final loading takes place. So in the notes, we have just mentioned one line or 2 lines maximum for each of the functions. But look at the marks. When 8 marks is given, you should talk about how memory is allocated. So memory allocation, there is nothing much discussed in our syllabus, but we have something about program linking. How program links, that diagram is there. That we have to explain to some extent. Then what is relocation? Talk about relocation bit. Then what is loading? Talk about linking loader, how it is done. So you have to cleverly understand the question properly and write and fill up the data. So if you go with the notes is only for you to understand what are the basic points. But looking at the marks, you have to fill more details as per the requirement of the question. So that we have to wisely complete that. So otherwise, functions of loader are only 4 in nature. Next, they have asked pass 1 algorithm and pass 2 algorithm. Both they have asked here for 12 marks. So you have to write both the algorithms what we have along with the data structure, that is external symbol table. It is a straightforward question. But 2 algorithms are asked, but 12 marks. So all chances of getting good marks are there here, but you should write both the algorithms. Next, another alternative in module 3, linkage editor and dynamic linking, which is again important to understand the various designs of a loader along with the comparison on linkage editor and dynamic linking. And there are diagrams, and all those diagrams are very important. Next, absolute loader. So in the beginning of loader itself, we have discussed about what is an absolute loader and bootstrap loader. And absolute loader, we have an algorithm. We can write a small program for that as well. So which is simple in nature. So that is a absolute program. It's a very straightforward question again. So this is about the module 3. Now we have a module 4, which talks about macro processor. So again, straightforward. What is a macro definition and what is macro expansion? The basic definitions and with examples for 6 marks. And explain the complete algorithm for macro processor is 14 marks is asked. Normally, since it is a bigger one, they need to ask for a better marks. So this time they asked for 14 marks to discuss about the entire macro processor algorithm. We have 5 subparts. All those 5 subparts need to be explained. There are again pseudocode. That's what we discussed earlier as well. You cannot by heart this. You can only understand the flow of the program. So that's how it is required. So alternative to that, concatenation of macro parameters, keyword macro parameters. So what is the concatenation of macro parameters? When you take a array type of macro parameters where alpha 1, alpha 2, alpha 3, alpha 4 you want. So alpha is a repetition here where 1, 2, 3, 4 will be changing. So instead of alpha, we'll give ampersand ID arrow mark. When I call in the macro call with alpha, so wherever ampersand ID arrow mark 1 is there, that gets replaced with alpha 1, alpha 2, alpha 3. So that is the concatenation of macro parameters. Second, keyword macro parameters, which is similar to a default arguments where all those parameters which we are supplying can be given a default values in the definition itself, and when they call also, we can change their values or change their order also. Otherwise, changing order becomes a stringy, thereby you may not be able to get the proper answer. So when we have a more number of macro parameters involved, it is advised to go with the keyword macro parameters so that order of them can be flexible. So that is what keyword macro parameters. In every case, if you look at the size of marks are very good, 8 to 12, 14. So you should always illustrate with the example. Simply write 2-3 lines, you may not be getting marks. So to get the attention of the examiner, to get better marks for your efforts, always write examples. If one example is not sufficient, take one more example. So try to provide justification to the marks that have been given. So if not one, write 2 examples, but give room for the examiner to think that you deserve these marks. Otherwise, simply 2-3 lines if you write as per notes, it is not sufficient. So you should also think in the real time. Next, we have a recursive macro expansion. This also we have seen as far as the one of the feature of macro processor is concerned, where recursively when a macro gets expanded, what is going to happen, how your argument table is going to be affected, all those stuff we have seen, and this is what the recursive macro expansion. So that is module 4. Coming to the module 5, the last one, which deals with the compilers. Explain the recursive, it should be recursive, not recursion. Explain recursive descent parsing. Write recursive descent parse tree for read statement. See, statement is not given here. So read statement, you know that it is going to have read within bracket ID and ID list and stuff like that. Normally, you're not expected to by heart this, but at least since it is a very familiarly used, so please try to remember this. But in the exam, they would have given the statement. Without statement, you cannot assume something. But since you know that a simple statement, probably we can work with that. So otherwise, you can assume something and start writing. Nothing wrong in that. But what is important here is that recursive descent parsing. What type of approach it is? Is it a top-down approach or a bottom-up approach? We have to identify. Accordingly, we have to develop the solution. So recursive descent approach, as the name says, it is a top-down approach. So what we are going to follow? Descent parsing, recursive descent from top to bottom. We are in the descending, that means top to bottom. That's how we can remember top-down approach. And read statement, one diagram we have to write, that is a parse tree. Good marks, 10 marks are given. Next we have whether we can recognize automata. I think this we have discussed as well. So automata representation. Next, define the terms grammar, lexical analysis. So define means don't stop there. Definition means one line and you will get marks. No, the question might be different, but look at marks always. Grammar, you should write about grammar, which is a BNF grammar, but what you have taken, and write some of the examples of a grammar rule, maybe from Pascal or whatever it is. And similar lexical analysis, we have taken lexical analysis, how it is being done. We have given notes as well. You can go through that and try to write some points with some examples again. So everywhere, minimum whenever 2 to 3 marks questions are asked, anything above 2 to 3, you have to illustrate with the example. Otherwise, you will not be able to get full marks. So next and last question of module 5, using the BNF grammar, represent syntax analysis for the Pascal statement. This you have done many a times. The statement is var sum dq. So we can write the statement, syntax analysis, which is nothing but parse tree. But if you write one parse tree, you will not get 10 marks. You have to develop multiple parse trees. For mean into mean, one parse tree. Some SQ divided 100, another parse tree. Clubbing them, another parse tree. One more parse tree. Like that, 4 or 5 parse trees we have to represent. Then only you will get 10 marks. Otherwise, simply one parse tree if you write together, you will not get marks. So this you have to remember. And these all things we have discussed as well. And notes is available with you. And last question is, discuss different machine dependent code optimization. So they have not asked you this we have to discuss or that. They have just given a very general question, machine dependent code optimization. We have discussed the 2 where we can have the quadruples, that is intermediate form, to minimize or to remove the variants both in the loop as well as in the program. So removal of the redundant values is what we have discussed, and converting them into blocks. So these are the two things what are seen as a mission dependent code optimization technique. So this is how the questions will appear and answers you have to provide, but you have to be very clever enough to use this particular what to say environment, and make sure that by writing all examples or more examples, that possibly you should be able to get better marks. So that you have to practice and plan well. Otherwise, whatever we have discussed, everything will be useful to you in answering all these questions. So this is about the recent paper that your seniors had. So probably we can look at the other one. Maybe 2019. Let me go through that. Yes. So this is another paper which you can consider. Let me present. So any doubts in that previous question paper? If you don't have any doubts, we can move this. Yes. Now, hope it is visible now. So for your super seniors, the code was different. So don't worry about the code, but the syllabus was same. So you can expect the same questions. So probably you can go through this. If you have any doubts, you can let me know. And meanwhile, I want all of you to write the 2B solution for 2B. So read module 1, question number 1 and 2. Get me solution for 2B. So now it is 2:25. I will get back to you by 2:35. In next 10 minutes, let me have solution for 2B. And if you have any doubts before this question number 1 and 2, also you can let me know. So I will get back to you in 10 minutes. May have some answers, solutions. Anybody has done? Find the target address of the following instructions.
Sir,
Hmm.
sir, they give PC value here.
They are not given. Yes, perfect. Next, what next? You can't do.
Yes, and here for the second sum we need base addressing and index addressing. They didn't even give that value
Okay.
too. Yes, sir. I tried the first sum, but I didn't.
How about the last one?
I didn't try, sir. Last one I didn't.
Last one is the 4 bytes. No, you don't require any PC.
Yes, sir.
See, the question is correct. That means what you are asking. So when they are asking, they should give the values of PC, X, whatever it is. So when such things ask, you should not neglect. You can write first one. Let us say if a PC base, you can boldly write and highlight that the based on the PC value, the target address can be considered. However, I am assuming PC has 5000. Accordingly, this is my address. You should conclude like that. Similarly, the second case, if base is involved, you should say base address is required. However, I am assuming base is so much. Accordingly, my result is that much. So when the values are missing, you have an option to assume, but you should clearly mention that I am assuming. Got? So you should be doing that. And the last one is format 4. So format 4 does not depend on either PC base. You can straight away calculate the last 5 characters as an address. And the third one, just check if it is immediate or whatever it is. If that is the case, you can get the value. But wherever data is missing, you can assume, but you should mention very clearly, I'm assuming, and take it forward. Then try the 3B as usual, as we did last class. It is very simple program today compared to the yesterday's. So I will come back to you in next 5-10 minutes. So try the 3B. If anybody is ready, you can start displaying. I will remove the screen sharing from my end. I will stop it. This program is relatively very simple and small program. Hope you should be able to do fast.
Sir.
Yes. Maithili.
Sir, question.
Tell.
Sir, I need opcodes for LDS ads for doing object code.
Don't worry about opcode at this point. Just give the address.
Okay, sir.
If address are okay, next step we will see.
That I have done, sir.
And opcodes are already given to you, in the appendix. I think document has been shared earlier, not in the question paper at least. At least the data has been given when we started discussion of the module 1, right?
Yes, sir.
Yeah, we can use that for understanding purpose. But at this point of time, let me know the machine address that is being generated.
Sir.
00 clear LDS plus idea adike. Okay.
Yes, sir.
256 you have to convert into hexadecimal and add.
Yes, sir, I did that.
Okay.
First 256 into 3, I got 768. 768 hexadecimal is 300, sir.
Okay, done. Perfect. Okay. So now probably you can write the object code in the similar form, and opcodes are there with you. You can refer your manual that we have shared earlier, and probably we'll wind up today and we'll continue in the next class. Okay. And meanwhile, who is the class coordinator here? Murli Krishna is there?
Yes, sir.
I told you 2 days back, Murli, about the classes where revision will happen from the students now. So,
Sir, I think
Huh?
it's good you only give us topics.
No, I have prepared. My list is ready.
Yeah.
Just giving an option for the students. When I give list, there is no question of changing. USN wise, I have listed in the syllabus order.
Okay.
Whatever the topic I have given, they have to say. Now, at least I am giving an option for them. They can come with their own topics. Anyhow, tomorrow morning class, if you don't get anything from them, inform me. I will display my list. Okay?
Okay, sir.
Fine. Done. Thank you. So we'll wind up. We'll continue in the next class.